Okay, test today. We're going to go over any questions that you have over 313, which I know was like forever ago because it was spring break plus a couple more days because it was Wednesday. We're going to cover 314. That is the last section. The last section. So the chapter test is pretty quick. Yes? Because it's the last section. We do have, I think we have 2 days for review. This is by far your hardest test you've taken all year. Not even close. It's not even close. Most of it, truth be told, is because it's all new to you guys. That's really what makes it hard. Most of the stuff we've done this year, 3.1 through 3.7, well, it was new too for the most part. But units 1 and units 2, a lot of that was repeat. Yes, there was new stuff added to it, but a lot of that was polynomials, right? Logarithmic, stuff that you guys are at least somewhat familiar with. Most of this stuff is brand new. And so I think that's what makes it the most difficult. The solving equations and the solving inequalities by far are the hardest things. Polar points, I hope was not that difficult. 314 today's bad. It's bad. If you know your unit circle, it's not that bad. If you know it and you're really, really comfortable with the unit circle, it's not that bad. If you are familiar with the trig graphs, trig, sine, cosine, it's not that bad. So if you are familiar with those two things and you're really, really comfortable with it, then this is not that bad of a lesson. And if you don't know those two things, this lesson is brutal. Yes, sir. Is there a 315 too? You already know it. I don't have to teach it, but yes, I guess there is. I'm sorry. I did not know there was a 315. 315 is it's the same 215 and 115 and 315. They're all the same. We give you the points and you find the graph and plug some points, and it's all calculator stuff. Okay. Again, guys, I know this has been a long time ago. We had polar points. You had to graph polar points, and you had to graph or turn polar points into rectangular points and vice versa. Again, I hope that that's not that difficult for you. However, again, I know that was a long time ago. You got to know how to do that in order to do today's lesson. Again, I know that was forever ago. You had to plot A, B, C, and D on the graph. The negative ones are the ones that get you. I hope that those were not bad at all. The negative ones are the ones that students miss. For number 2, those are the ones that students miss. On the test, you'll have to graph A, B, C, and D, and it's always the negative one that students miss. Just remember that you're going to that angle and you're basically turning around and going the other way. So you're looking at that angle, but then you're going to turn around and go the opposite way. And again, remember, you can name each one of these infinite ways. You don't have to name it -3, 5 pi over 6. And that will be a question on your test. Give me another point for this one. Okay? That wasn't it. Why are you frozen? There you go. Plot, convert. Any of those you need help with, something you want to go over. Anything. My goal for you guys, let's see, I've pretty much caught up on everything that you've done, unless if you did stuff over break. This was 13. 312 I don't have in the grade book. 313 I don't have in the grade book. And if you took a retest, I don't have that in the grade book. Yay? Some of those I do, but a lot of them I don't. If you've taken a retest, I don't think I've put those in yet. That means a bunch of you guys that are wanting to take retests, you're running out of time. And we're getting ready to take another quiz. So now you got some more quizzes. If you guys want to try to do these retakes, you're running out of time. Just Remember all that stuff. If you keep putting it off and keep putting it off, you won't have time to do it. I really frown on you guys coming in and looking over your quiz and taking the quiz at the same time. I don't like that because I don't think you learn from that. If you want to look at your quiz, you can, but then I don't want you taking your test because I think that's short-term memory, and that doesn't help you. That's not what it's about. It's for you guys to learn it so you guys can do well on the test. Okay? So you're running out of flexes. Running out of flexes for that. No questions at all on this. Nothing at all. Nothing. Converting them, anything. Nothing. All right, here we go. Please, I beg you, pay attention, take your notes, write down extra stuff. These are not easy. Not. Okay. Polar graphs. We've looked at polar points. Now we're going to look at polar functions and or polar graphs. Okay? We have learned and explored how polar coordinates work. It is only natural we begin to explore how the concept of polar functions and their graphs. Polar functions, the inputs are theta, your independent variable, the angle. The outputs are your radius. On the AP Pre-Cal exam, questions may use the phrasing below to introduce a polar function. This is what you're going to read. The graph of a polar function R equals f of theta. So again, recognize you got R's and recognize you got thetas. We don't have X's and Y's. And f of theta is going to be some function. Here they have 3 and a -3 and a sine theta. This one's actually not too bad because we've only done a couple of things to it. It's shown in the polar coordinate system from 0 to 2 pi. So again, they'll narrow the domains down typically to 0 and 2 pi. So you know that it will continue on. You could go from -infinity to infinity. Most of the time, they're only going to go from 0 to 2 pi. You should know how to graph that rectangular. You should know how to graph that rectangular. And again, if you know the unit circle and you know how to graph that rectangular, this is not that bad. Really quickly, let's do a reminder of that. Sine typically starts at 0. Sine is the one that starts at 0 and does that. Cosine starts up here and comes back up that way. Oh, okay, I kind of remember that because the sine of 0 is 0 and the cosine of 0 is 1. This 3 right here changes the amplitude. And this 3 right here moves the whole thing up 3 units. Oh yeah. That changes the period. The period is 2 pi. And if there's something with that theta, that shifts it left and right. Oh, you need to know all that stuff because that's on your test, right? Even though we took that test part, it's still there. So graphing polar functions. Creating a table of values is always a good strategy when attempting to graph a new or unknown function. You can graph anything with a table, anything at all. If you don't know what that graph looks like, you can graph it by a table. At some point, you'll get a good idea of what it looks like. The more you graph, the more it looks good, right? The less you graph, the more you have to guess what happens. We're going to look at that 3 -3 sine theta to be a polar function with a polar for 0. We want to sketch that graph in the axes below. So I have no idea what that graph looks like. You don't have any idea what that graph looks like. So we're going to kind of plug and chug and kind of get an idea of what that graph looks like. theta is 0. If theta is 0, then I'm going to take the sine of 0. And the sine of 0 is 0. 0 times 3 is 0. And 3 minus 0 is 3. Y'all see what we're doing? Kind of just plugging and chugging. There's going to be some nasty points on here, and there's going to be some nice clean points. Pi over 6. Pi over 6. Now, be careful with these graphs. We're used to seeing pi over 6, pi over 4, and pi over 3. You're not used to seeing those two. Let me rephrase that. You're not used to seeing, you're used to seeing this one and this one. This one's the third, that one's the fourth, the sixth, the fourth, and the third. So a lot of times they don't label those. So you need to recognize they put extra ones in there that you guys are not used to seeing. We're used to seeing the thirds. We're used to seeing the fourth, pi over 3, pi over 4, and pi over 6. Pi over 2. So we're used to seeing this one, not this one, not this one, this one, this one. Y'all good? A lot of times they don't label those graphs. Pi over 6. Sine of pi over 6 is 1/2. That's when it's the short one. 1/2 times 3 is 1.5. 3 minus 1.5 is 1.5. Let's go ahead and plot these points as I go. 0, 3, 2, 4, 3. Oops. Zero, 3. Let me rephrase that. I'm sorry. I do that. That's bad. It's 3, 0. They do radius first, then the angle. Radius first, then the angle. Pi over 6 is 1.5. Here's 1. There's 2. 1.5 is like right here. Okay. All right, pi over 4. Pi over 4 is the square root of 2 over 2. Square root of 2 over 2 times 3 is 3 roots 2 over 3. 3 minus 3 roots 2. Yuck. Decimal. Nasty. Nasty. Let's see what it is. Sorry, I should have turned my calculator on earlier. Are you going to go? Anybody got that? 3 minus 3 root 2 over 2. Punch. Wait, you got it? I got it. 3 minus 3 root 2 over 3. 1.58. Root 2 over 2. I knew something was wrong. Root 2 over 2. That looks better. 0.87. 0.87. So pi over 4 is 0.87. So here's 1.87 is like right there. One third, it's square root of 3 over 2. Square root of 3 over 2. Square root of 3 over 2 times 3 is 3 root 3 over 2. So let's figure out what that is as a decimal. 3 minus 3 root 3 over 2. 0.4. And pi over 2. Sine of pi over 2 is 1. 1 times 3 is 3. 3 minus 3 is 0. Yes?
Why in this case is the right column on the y value?
why is, so when you're given the ink, that's how polar coordinates are given to you. R theta, right? Okay. Glad y'all good. What else? Everybody else okay? That's what I do that backwards a lot because you got to go to the angle first to figure out what the radius. I don't go to the radius and then go to the angle. Like if the radius is 4, I know it's somewhere around here, but I don't know where it is. So I go to the angle first, and I don't like R first, but that's the way they give it to us. Good. 2 pi over 3. 2 pi over 3. Y'all okay with symmetry? Right? Because 2 pi over 3 is going to be the same thing as pi over 3 for sine. 2 pi over 3 is going to be the same thing as this. So 2 pi over 3, which is here, is going to be back at that 0.4. And 3 pi over 4 is going to be the same thing as this pi over 4, which is 0.87. Yes?
I thought we used the middle 3 points, not the outer one.
Middle 3. Is it this one, and this one? Those shouldn't be equidistant. A third's further. For homework, they're showing these two. Those? 6th, 4th, 3rd. How many are there? 1, 2, 3, 4, 5, 6. They're going by 12ths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 12ths. 11 12ths. 10 12ths. Okay, y'all with me? Sorry, messed up my fractions. 1/12, pi over 12. 2 pi over 12. 3 pi over 12. 4 pi over 12. 5 pi over 12. 6 pi over 12. 7, 8, 9, 10, 11, 12. Thank you for fixing that. They should label those. Now we've got that fixed. We're back at where we're at. What's this pi? Sine of pi is 0. 0 times 3 is 0. 3 minus 0 is 3. Two, 4, 3. Good. Sine of 7 pi over 6. 7 pi over 6. That's negative 1/2. Negative 1/2 times 3 is negative. Oh, it's a negative, though. It's a negative. It's a negative 3. So it's positive 1.5. And 3 plus 1.5 is 4.5. So let's see, 4.5. $4.5. 5 pi over 4. I got to go back to my calculator. 5 pi over 4 is negative root 2 over 2. 3 minus 3 negative root 2 over 2. 5.1. 5.1. This is 4. This is 5.1. 4 pi over 3. 3 minus 3 negative root 3 over 2 negative 5.5. Was it negative 5.5? Okay. Sorry. I did that wrong again, didn't I? $45. Okay. 3 pi over 2. Good one. 3 pi over 2 is negative 1. 3 minus 3 times negative 1 is 3, 4, 5, 3, 12, 4, 8, 1, 6. I was just messing up, but y'all good? 6. Sine of 3 pi over 2, that's negative 1. Negative 1 times 3 is positive 3. 3 plus 3 is 6. And we're going to have a mirror image on the other side for symmetry. Wow. Yay? Yes.
We need to solve the unit circle if we have our calculator. We just do the whole equation.
You will not have your calculator. These are non-calculator questions. They call this a cardioid. Kind of looks like a heart. Yay? You don't care what they're called. They can look like all kinds of different things. They can look like a circle. They can look like a rose. They can look like a propeller. Yes?
What's the word behind the shape and exact points?
We sketched it.
Yeah.
Fair? We sketched it. If it was sine instead of cosine, it's going to look close to the same. Again, all this stuff, you really don't care. It's interesting how they work. But the heart shape would be here, and it would circle around one of these axes instead. So this thing would kind of be rotated because sine and cosine are the same graph except shifted. So if you shift this thing or shift it, yay, soak all that stuff up. Let's see what it says here. It's not common for polar function to display, it is very common for polar functions to display symmetry. We can use our understanding of symmetry to help construct these polar graphs quickly and easily. Guys, we're not going to graph a polar function step by step by step. You're not going to have to graph a polar function at all. You don't have to graph one. You have to look, know how to read them and know what's going to happen. That's what we're going to try to learn today. On the AP Pre-Cal exam, polar functions will only appear in multiple choice. This means you will not be required to sketch a polar function by hand. However, students will be expected to understand polar functions, their graphs, and what portion of the graphs exist with various domain restrictions. When working with multiple choice questions involving polar functions, it is advantageous to evaluate the function at several values of theta, which is exactly what we just did in that table. which means you need to know the unit circle. And the faster you know the unit circle and the better you know the unit circle, the better you can plug and chug and get those values. We're not going to plug in those weird points. We're going to plug in the zeros, the 1/2s sometimes, the zeros and the ones. Go with me on that. I'm not going to use pi over 4. I'm not going to use the root 3 over 2, whichever one, if it's sine or cosine. I could use the 1/2s, I could use the ones, and I can use the zeros because those I can do in my head without a calculator. Here's example number 2. This is a rose. It's a 3-leafed rose. Notice, oh, I don't know what the function is, but that's a 3-leaf rose. The figure shows a polar function, r is equal to f of theta. I'm sorry, yes, and theta is between 0 and 2 pi. Again, very, very common. So this is one period graphed. Which of the following could be the expression of f of theta? This is the type of question you're going to see. They're going to give you the graph, and they're going to ask you which one of these functions could it be. And what I would do here, guys, is find a point over here. A point. Probably not 0, because it looks like 0 hits a lot of times. Maybe that point. Maybe this point. Maybe that point. I could use this point, but that point could be one of a bunch of points. Like, I don't think I'd use 0 because it doesn't help me. I don't know which angle I'm at for 0. If it's 0, that could be any one of the angles. That angle we've decided now is pi over 6. Here's pi over 4. Here's pi over 3. Notice at pi over 3, I don't have a point at all. Fair? Pi over 3, I don't have a point. Remember, you have negative points also. So I'm going to use this pi over 6. And I see this pi over 6 right here, and I'm going to plug it in over there, and I better get 3. Because the radius is 3 at pi over 6. So I'm going to go over here, and I'm going to do pi over 6. And 3 times pi over 6 is pi over 2. Hopefully you can do that. Sine of pi over 2 is 1. 1 times 3 is 3. This is looking good. I'm not going to say that's it, because there could be a couple that give me that point. Let's go to this one. Sine of pi over 6 is 3 times pi over 6, which is pi over 2. Sine of pi over 2 is 1. 1 times negative 3 is negative 3. Now, you guys have to remember this. Pi over 6 negative 3 would put it here. Negative, you turn around and go the other way. And there is not a point on that graph that gives me this. Let's go to cosine, because both of these are cosine. What do we know about cosine of pi over 6? Okay, pi over 6 times 3 is 3 pi over 6, which is pi over 2. Cosine of pi over 2 is 0. 3 times 0 is 0. That could be a point on this graph. Because that's pi over 6, 0. Oh. Yes, that is pi over 6, 0. So that could be a point on this graph. Don't know for sure. Could be. We want the correct answer. We don't want to guess and hope we get it right. So pick another point. Pick another point. Let's pick 0. Just pick 0. 3 times 0 is 0. Cosine of 0 is 1. 1 times 3 is 3. At 0, I don't have a point at 3. Now I know that this one is not the graph. It looked like it wasn't a graph. Pi over 6. 3 times pi over 6 is pi over 2. 3 of pi over 2 is 0. 0 times negative 3 is 0 again. Find another point if you want. You'll realize quickly it's not. If you wanted to feel better about this point, then find another point. Use your answers to plug and chug and see. Just because the first one works does not mean it is the one. It can work for other points. Yes, no, maybe. The more you do of these, the more you'll start seeing what it could possibly do. Okay? We did, that first one we did gave me a cardioid because it had a number out in front. It had a number all by itself. It moved the graph up. If it moves the graph up or down, it's going to make a cardioid. This one was not moved up or down. I just have a number in front. I changed the amplitude. Yes, I changed the amplitude was it. And then that 3 tells me it's going to happen 3 times as fast, right? That changed my period. So because that 3 is there, basically that's why I have 3 petals. If this was a 5, I would have 5 petals. If this was a 1, I would have 1 petal and it would just be a circle. It would be a circle if that was a 1. So the period is telling you how many petals you have. Okay with all that? You don't have to know that, but it's a little helpful to you. I changed my notes up a little bit from you guys, I know. This one's kind of a cardioid, except I got another loop inside of there. Whatever, okay. Notice that I have a sine and a sine and a theta and a theta and a theta. They're all theta, so this only happens, we have one period goes from 0 to 2 pi. That's why it's not repeated per se. It doesn't have the petals, okay? Same type deal. We'll plug and chug, and you're going to find any point that you want. I think I would start off with 0. I would start off with 0 because 0 gives me a radius of 2. Sine of 0 is 1. 1 times 4 is 4. 4 plus 1 is 6. That doesn't look good at all. Sine of 0, 0. That's what I said, yes?
And 0 times 4 is...
0 times 4 is 0. Now that's 2. Sorry. I can't do math. I did the trig part right. Good. Can't catch you. Sine of 0 is 0. 0 times... This is 2. Crap. Not looking good. Cosine of 0 is 1. 1 times 4 is 4. 4 plus 2 is 6. It ain't that one. Because at 0, I do not have a point at 6. Cosine of 0 is 1. 1 times 4 is 4. 2 minus 4 is negative 2. It could be that one. It could be that one. 0, negative 2. Remember, negative makes you go the other way. Pick a point. You want to try pi? We can try pi. If you want to try pi over 2, we can try pi over 2. If you want to try 3 pi over 2, try 3 pi over 2. The more numbers you try, the more chances you're going to have to get it right. If you did all 4 of those, you will not miss it. You can't. You can't. You have plenty of time on the AP exam. Test as many points as you can. Pi over 2. Pi over 2. Sine of pi over 2 is 1. 1 times 4 is 4. 4 plus 2 is 6. Did I do that one right? At pi over 2, I do not have a point at 6. Sine of pi over 2 is 1. 1 times 4 is 4. 2 minus 4 is negative 2. And at pi over 2, I do have a point at negative 2. See, that's what's hard, is you guys got to, I don't have anything at pi over 2. Yes, you do. I actually have several points at pi over 2. I could have a 0, I could have a negative 2, or I could have a 6, or I could have a positive negative 6. There's a bunch of points I could have at pi over 2. Cosine of pi over 2 is 0. 0 times 4 is 0. 0 plus 2 is 2. Well, we already marked this one out anyway. I don't know why I'm testing it. Cosine of 0 is, cosine of pi over 2 is 1. 1 times 4 is 4. 2 minus 4 is negative 2. Yep. I know. You caught it. Cosine of pi over 2 is 0. 0 times 4 is 0. 2, that's positive 2, and I don't have anything at positive 2. It's got to be that one. And if you want to test more points, you can. But by the time you've tested a couple points, you probably have narrowed it down. A portion of the graph has been drawn. And the graph is negative 3 sine theta. That's the graph. It's shown in the coordinate system from A to B. And we know that 0 has to be bigger than, A has to be bigger than 0. And B has to be less than 2 pi, but B has to be bigger than A. In other words, we have one period, and A is some value, and B is some value between 0 and 2 pi. But A has to be less than B. Which of the following could be the values for A and B? In other words, is that the graph from 0 to 2 pi? Or is that the graph from, pi over 2? Or is that the graph from pi over 2 to pi? Or is that the graph from 0 to pi? Or is that the graph from pi to 2 pi? Well, I don't know. It's only part of it. Which part is it? Plug and chug. Plug and chug. I don't think I would choose 0. Because again, 0, you can choose 0. I better get 0. Because there's no graph out there, right? how about this? Let's go back to this. Look at it rectangularly. Look at it rectangular. Don't look at it polar, look at it rectangular. What was it? -3 sine theta? -3 sine theta. This is just sine. Sine starts at 0. It typically goes up to 1. This one would go up to 3, except it's going to go down to 3. Y'all with me on that? That's the rectangular graph of -3 sine theta. This is 0. This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. Y'all good? I want to try to get that information to go there. And if I look from 0 to pi over 2, this graph is negative. From 0 to pi over 2, this graph is negative. So all my R values will be negative. All my R values from 0 to 2 pi will be negative. It can't be from 0 to 2 pi. From 0 to 2 pi, I'm sorry, I keep saying 2 pi. From 0 to pi over 2, my R values are negative. That puts my negative values down here, and I don't have any graph down there. So it can't be from there to there. Let me go through that again. Graph it rectangularly. It will help you. From 0 to pi over 2, this graph is negative. So from 0 to pi over 2, I have negative points. We'll put it in quadrant 3, and I don't have any points in quadrant 3. Pi over 2 to pi, I have negative points. Pi over 2 to pi, I have negative points. It's looking okay. I'm not saying that's it, but that's looking okay. Pi over 2 to pi, I have negative points. Maybe. From 0 to pi, I have symmetry. Y'all kind of see that. I don't have symmetry up there. If I had symmetry, I would have to either go this way or I would have to go this way. I would have to do one of those two for symmetry. And I don't have that. And from pi to 2 pi, I got the same situation. I have symmetry. I have 2 points that give me the exact same thing, and I don't have symmetry on that graph. In order to have symmetry, I've either got to finish it out here or I have to have it up here. One of those two has to be there. Which one? I don't care. It's not there. That one has to be the graph. Doesn't always help you to find out which one's right if you can find out which 3 are wrong. Hopefully you get a little bit more comfortable with this as you do these. Yes, sir.
Can you just skip graphing it?
Yes. 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 Don't have to do this horizontally. You don't have to do it, let me re-say that, rectangularly. This is rectangular, that's polar. Right? We changed polar to rectangular points earlier in 3.13. That changes the two graphs. Okay? This graph would look just like this. It's just going to be a circle with a radius of 3. It's a circle with a radius of 3. There's nothing with the theta, and then there's the 3 there. And then the negative just makes it go down instead of up. So if it was just 3 sine theta, it would be a circle up here. If it was 3 cosine, it'd be a circle over here, and negative 3 cosine will be on the x, sine will be on the y. We'll do more of these. Same question, different graph. A portion of the graph from 3 cosine 3 theta, oh, that's a rose, has 3 petals, radius of 3. That's why it goes out to the 3. So I can almost sketch this thing. There's one of them. I bet there's the other one. And I bet there's the other one. If there's 3, they have to be symmetric. You can't put one on the x and one on the y and one on the x, because then you're missing down here. You don't care. I recommend drawing it rectangular. Cosine starts up top. Because it's positive, it's going to start up top. If it was negative, it would start down low. That's 3. This is negative 3. That should be 2 pi, but it's not 2 pi because the period got changed to 2 pi over 3. You take 2 pi and divide it by b to get the period. Oh, I kind of remember that. If that's 2 pi over 3, then right here has to be 1 pi over 3. And half of that has to be pi over 6. 1 6, 2 6, 3 6, 4 6. I don't know if that helps you or not. Most of the time it helps you to draw it rectangular. That is this graph rectangular. There it is polar, but it only has part of it. It only has part of it. So I need to know if I'm going to go from pi to 3 pi over 2, and I only have pi on my graph. I guess I could keep on going. Yes, I could. 0 to pi over 2. 0 to pi over 2. I would have symmetry here and here. I would have to have symmetry. I don't have symmetry. Yay? I don't have symmetry. From 0 to pi over 3. 0 to pi over 3. I have positives and I have negatives. Maybe. 0 to pi over 6. Oh, I just got positives. I just got positives. I like that. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Plug in pi over 6. Plug in pi over 6. Is it cosine or sine? Oh, it's cosine. Dadgummit. I don't want to plug in pi over 6 for cosine. Yep. Oh, so it works out good? Okay. Y'all see what we're saying? Pi over 6. Pi over 6 times 3 is 3 pi over 6. 3 pi over 6 is pi over 2. 3 of pi over 2. Straight up in the air, 0. 0 times 3 is 0. Pi over 6, I better be at 0. I could be. 0 doesn't help me. Okay. 0. Cosine of 0. 3 times 0 is 0. Cosine of 0 is 3. 1. Cosine of 0 is 1. 1 times 3 is 3. Ooh, that looks good. 0. I'm at 3. I go down. I'm decreasing until I get to 0. Yes? My R, my radius is decreasing until I get to 0. I like that one. I didn't like this one. That was too big. I'm not too sure I didn't like this one, but I think that's too big also because it would have had symmetry. It would have had symmetry. Hit me. Correct. Like I said, as you do more of these, you should start getting a little bit more comfortable. I think these are the hardest by far. I think these are the hardest by far, figuring out that range of where that graph is. Yep.
Could you just explain how you got that answer?
You okay with how I drew it here? You okay with pi to 3 pi over 2? That would have symmetry in it. And this one had symmetry in it. And that one doesn't have symmetry. Well, because in order to have symmetry, I'd have to have one of two things. I'd have to either have this part of it, or I'd have to have this part or this part of it. I have to have another portion of it somehow. And so that's the only one that didn't have the other portion of it. Because from 0 to pi over 6, it just shortened of it.
Okay.
I plugged in 0. I plugged in 0 and I got 3.
Yeah.
I plugged in pi over 6 and I got 0.
So just following the rectangle graph.
And so that part of the graph is that right there. Good. Yep.
So we're trying to find, if they chose us a quarter of this graph, we're trying to find the quarter that is the correct values and also mirror.
Why are you saying a quarter of it?
Because it's showing us a quarter. It's showing us the first quadrant.
1/4 of the 3 petals?
Okay.
I don't know. That's what I'm asking.
It's showing us one quadrant.
Yes.
And the one before this is showing us another one quadrant.
Okay.
We're trying to, because pi over 6
Correct.
is a fourth. We're looking for the fourth.
Yes.
That has the correct value.
Yes.
Okay. Awesome.
As you do more of these, you'll start getting more comfortable with that part of it, I hope. I hope. The first year I thought this, gosh, it was brutal. Horrible. And I finally had somebody tell me that draw them rectangular. And that helped out a lot. You don't have to. It helps you. I think these are easy. I hope you do too. The figure shows the graph of the polar function 6 cosine 3 theta. Hopefully you guys now understand 3 theta is going to give me 3 petals. Look, I got 3 petals. 6 is going to give me the radius, so it's going to go out to 6. So hopefully you can kind of start seeing that. It's not a cardioid because it doesn't have a number out here all by itself. It has a number out here all by itself. That does the cardioid. Sometimes it does a cardioid with a loop in it. I don't know what they call those. The portion is given and the graph remains consistent of 2 pieces. One of those 2 pieces is from quadrant 3 is from C to D. So y'all see the D and the A and the B and the C. So you have to be able to see those labels. The D is hard to see. There's a D, here's A, here's B, and here's C. They're telling me that if the domain is restricted from pi over 3 to 2 pi over 3, that's not restricted. That's from 0 to 2 pi. If I restrict it from pi over 3 to 2 pi, the portion of the graph that remains consists of 2 pieces. One of those pieces is in the portion of quadrant 3 is from C to D. That's one of the pieces from pi over 3 to 2 pi over 3. I need, and then which of the following describes the remaining piece? Draw it rectangular. What was it? 6 cosine 3 theta. Cosine. Six, negative 6, 3 theta. 2 pi over 3 is the period. Just like last time, if that's 2 pi over 3, the middle of this has to be pi over 3. That has to be pi over 6. And that has to be pi over 2. 1, 6, 2, 6, 3, 6, 4, 6. You need to be really good with your fractions also. They're telling me, oh, now I can go back to this. Watch what I'm going to do here. At 0, I'm at 6, which is point B. At 0, I'm at 6. That is point B. At pi over 6, I'm at 0. At pi over 6, I'm at 0. Well, 0 is point D. That's a no-brainer. That's the only one that's at D. At pi over 3, I'm at negative 6. Well, where's pi over 3 at? Pi over 3 is this one, and I'm at negative 6, which is down here. That point is C. Whoops. And then I'm back at 0, which has to be D, and there's only a point left, so this one has to be A. They say it goes from C to D, and they tell me it goes from pi over 3 to 2 pi over 3, which is here to here. And if I go from C to D, the only thing I got left to finish it out is I have to go from D to A. Yes.
If you restrict the domain on the graph, would D to A be the only option?
It is the only option. That is correct also.
So what's the point of all that?
Did I know it before I did this?
But you can see how those block off this two domains.
I didn't say you have to. You're good with the unit circle. Y'all good? Everybody okay? Beautiful. I think this is a whole lot easier than those others. Beautiful.